We good now? Awesome. Well, good morning, folks. Thank you all for joining me for the first demo of the morning. My name is Nik Karpinsky. I'm a software engineer with Microsoft. I've been with Microsoft for approximately 12 and a half years, my entire career on Visual Studio. And most of that time I've spent on the Visual Studio Profiler. So I'm super excited to share some of my experience with Profiler today and some of the workflows that we've added into Visual Studio. But before I get started, I always like to kind of poll the audience, understand who it is I'm talking to. Who here is a .NET developer? Okay, so a pretty good amount of people. Who here has used the Visual Studio Profiler before? Wow, actually there's quite a few people. Who hasn't used the Profiler before? Anyone admitting? Cool, I'd love to talk to you afterwards and you can tell me why you're going to change your ways. Who has used benchmark.net before? Okay, a couple of people. Have any of you used the Visual Studio integration with benchmark.net, with the Profiler? One guy. Awesome. So I'm excited to share some of those new features with you today. This is going to be a pretty demo-heavy presentation, as it is the demo. I have a single slide that I want to walk you through, and this slide is going to help illustrate what that agent is doing as we go through the demo itself. And so this is my flowchart for how you actually optimize code in the real world. You start on the left, you work your way over to the right, and if you're successful, you get cake out of it. And so to start, you want to really make sure that you understand your issue. And so when I say understand your issue, I mean not just like, oh, hey, I think serialization is kind of slow, I should probably go take a look at that. It's really, I have concrete numbers, I know specifically where time is being spent in my application, and then I can use that to then try and improve this specific parts that are taking up the most amount of time, so I get the most amount of improvement for my investment. And so if you don't know what the issue is, that's okay. You just run the profiler in Visual Studio, and it will show you where time is actually being spent in your app. And then from there, you can figure out like where you actually want to spend your time actually trying to optimize. The second thing is, once you know what the issue is, you could jump into trying to optimize stuff, but it's really hard to try and optimize if all you're doing is just taking general traces of your application. And so I always like to try and say, like, go create a benchmark. It gives you this nice, reusable, durable test harness that you can go and test performance on. I like to think of a benchmark as a unit test for performance. So unit tests work with the debugger, benchmarks work with the profiler. And the nice part is like, once you have it, then you can fall into the optimization loop, and this is my favorite part. This is the part where it actually gets to be kind of fun, because all you gotta do is you measure, you make some changes to your code, and then you see the impact of those changes. And so like I said, you measure twice, you optimize once, you measure, you make a change, and then you measure again, and you can see the delta. You can see what the effects of your changes were. And so then afterwards, you get to the improve block. Did you actually improve the code? Yeah, cool, success, you get cake. If you didn't, that's totally fine. You can just fall back into that optimization loop. You can try a different optimization. It's not just necessarily a one and done, it's very experimental. And maybe you've gotten to a point where you've optimized so much for that one benchmark that you can't really improve anymore, and that's totally fine too. You can just go back to that first block and you can start looking at other issues that you might have had in that original trace and pinpoint something else to try and improve. And so with that, let's go ahead and let's jump into the demos. And so when I do demos, I always get super aggravated by someone taking a console app, putting in a very obvious bug and saying, hey, check it out, the tool showed me what the problem is. Like, that's just not realistic of what we do as software engineers. And so I always like to go to some sort of popular repository and see what I can do to try and improve performance. And so one of my favorite ways to do this is I go to NuGet.org, I just kind of scroll down some of the packages, see what's super popular, and in this case, for this talk, I want to see if we can optimize CSV helper. So it's the 16th most downloaded NuGet package at 51 million downloads, super popular package. If we can try and optimize that, we have a potential to really help a lot of people. And so what I did is I went ahead, I cloned it, I opened the solution in Visual Studio, And you can see there's CSV helper. There's already a CSV helper benchmarks project, which is awesome. That was actually added by yours truly in a previous talk. I've reused this repository a couple of times. We also have tests, which are great. So as we go through the optimization loop, we can run the test, make sure we didn't actually break functionality, because although we want to make things faster, we don't want to break things. And then there's the website. And so in the previous talk, I created a benchmark. And for those of you that aren't familiar with benchmark.net and how benchmarks work, this is just a very simple benchmark. It's, like I said, it's very similar to a unit test. There's a global setup piece to it, so you can do all kinds of initialization before the benchmark itself actually runs. This is great because you can extract the parts that you're not actually trying to measure. And so in this benchmark, it's trying to enumerate records. So it's trying to see how fast CSV helper can actually read a CSV file, but I need some sort of test data to test it on. And so this global setup lets me set that up. So I'm not benchmarking setting up my test data, right? I'm just benchmarking the actual code that I'm interested in, which is this enumerate records. Another interesting thing to kind of point out here is in this enumerate records, you see it starts off by setting the stream position equal to 0. What I'm actually doing here is in the setup, I'm creating this CSV file, and it's being put into a memory stream. And then I need to write that CSV file, and I don't want to pay the cost of constantly expanding buffers and flushing out to disk. I'm really trying to isolate the code that is doing the actual enumeration. And so I reset that stream and I keep it in memory. And so again, I'm just trying to measure the impact of the library itself. And so we have a benchmark for actually enumerating records. I want to go ahead, I want to try and create a benchmark for writing records. So we have the reading, now we can do the writing. And so I'm going to switch over to the Copilot chat, and I'm going to type @profiler. That says I want to talk to the profiler agent that knows about benchmarking, that knows how to run the profiler, that knows how to write benchmarks. And I want to say, write me a benchmark for writing a CSV file. And now Copilot's going to go off, and with any luck, it's going to go ahead and write that for us. And the first thing we can see is in the kind of little ghost text, there is a, let me see if I can expand that real quick. It read the existing benchmark. I didn't tell it about the existing benchmark. It knows that, hey, I'm writing benchmarks. I should probably look at the other benchmarks that are included in this project and try and write similar code. And so it found that benchmark. It then said, hey, there's no existing benchmarks that cover CSV writing. Because if we already have one, why duplicate that work? Why don't we just reuse the existing one? And so now it's searching through the project, and it's going to write out a benchmark. And then the first thing it says is, hey, it needs to install this benchmark packages, this diagnostics hub, benchmark.net diagnosers. I'm going to go ahead and say confirm. This was that integration that I talked about with the Visual Studio Profiler. Benchmark.net has this concept of diagnosers, which allow different tools to pull diagnostic information from the benchmark while it's running. Visual Studio has one of these packages published on NuGet that allows it to interact with the profiler and pull that data. And so it went ahead, it created the benchmark, it compiles cleanly. I can go and click on the write records, and you can see it wrote it in a very similar fashion. It still has that simple class. It does a global setup again. It does the write records. It sets the position. I don't want it to set the length of the stream because I don't want it to reset the stream every time. I just want it to reset its position in the stream. And then I want to change this a little bit. So I have this writing off this record that we're going to serialize off. And in this name field, it's just a bunch of random characters. I'm going to hit Alt/, and I'm going to ask Copilot to update this so half of the records have a comma delimiter in them. And so I can kind of work with Copilot to try and iterate on the benchmark itself. In this case, I want to try and add some commas to the fields because that'll make it a little bit more interesting, a little bit more realistic in my data. So you can see it took a very simple approach here where it just modded by 2, dropped a comma in there, nothing super, super crazy. And so now I have my benchmark. And so if you remember back to that loop, we now get to jump into the actual optimization part. And this is the fun part. And so I'm already talking with the profiler. It's already asking, hey, do you want to run this to establish a baseline? And I'm going to say, run the, and I'll type the hash, and you can see this menu pops up. And this is the way I can provide additional context to Copilot. And I can say, run the write records benchmark and optimize the code that it calls. And what that slug does is it provides that context to Copilot, and the better context you can provide it, the more likely it is going to be to do the operations that you want. And so I gave it that very specific, like, this is the benchmark that I want you to run. And so now it is reading through some of my files. It looks like it's reading benchmark.main. And it picked up on this fact that previously in the benchmarks, we only had a single benchmark that I added during my previous talk, and so I was just directly running that benchmark, and it says, hey, I need to be able to pick the benchmark that I want to run, so it automatically switched over to benchmark switcher, so it can control the benchmarks that run at runtime. And then behind the scenes, it's actually running benchmark.net. And so if you ran this in the debugger or you ran this from a terminal, you would normally get a terminal window that pops up, and it's going to have a whole bunch of spew that's popping out that's saying, like, hey, this is the iteration that we're on. This is how long each one of these is taken. You can see we're right about 1.4, 1.5 milliseconds. And so it would spew all that out. The agent's just capturing all of that, collecting it here, and then at the end, it's actually getting a benchmark. Or it's getting a profiling trace, I should say. And so it's saving to a directory, and then it automatically opens up in Visual Studio. And then it can start getting into the optimization. And so at this point, we have our benchmark. So we have that reusable test harness. We now have a trace from that, and so we know where it is that we want to, or we have a trace that tells us where time is being spent and where we might want to try and do some investigation. So I'm going to hit stop here real quick, because sometimes the agent gets a little excited and it says, hey, I see what the problem is. Let me go fix that. We've tried to tell it not to, but sometimes it gets a little excited. It went ahead, it did the analysis for us, and it said, hey, the biggest hotspot is this expression compile, followed by the should quote, and then this dynamic multicast delegate. And it's saying, like, hey, the biggest win, of course, is the thing that uses the most amount of CPU. Let me go ahead and try and optimize that. I'll be honest, I've tried to optimize this a couple of times, and I always seem to fail. And so I don't want to optimize the topmost item. And if you remember back to that pipeline, like I said, like, if you can't get the improvement, just go back and pick the next biggest thing to try and optimize. So instead, I'm going to say optimize the should quote logic. And so I can steer it down another investigation path. And so it's going to start thinking, says user wants me to investigate this other thing instead. So it's going to go and it's going to investigate the should quote logic. It's going through, it's reading relevant source. It is, and it's, the interesting thing here is it's not just grepping through your source base, it's using the go to source functionality and the profiler. It's using that profiling data to see exactly which lines are taking the most amount of time, and then it's using that to guide the investigation that it's doing. And so it is continuing to go through. And it looks like it says the best optimization is to combine the character checks into a single pass. And the should quote method looks like, you can click here. Looks like the should quote method had this really pretty little Boolean logic block that did a bunch of operations in very few lines, and Copilot saying, like, hey, you might be iterating that too many times, and instead, let's just do a single pass through, and let's try and optimize how we're iterating over it so we're not doing multiple iterations. And the interesting thing here is, as soon as it went and did that optimization, you noticed it said, hey, I need to rerun the benchmark to measure the improvement. And so this is the really important part. Again, like I was saying earlier, once you're in that optimization loop, you want to measure, you establish your baseline, then you change your code, then you always remeasure because you want to see what was the impact of that change. Because if you're not actually measuring with data, you're not optimizing, you're just refactoring code. And so the data is really what turns it from a refactoring into an optimization. And so we can see the result summary. Yep, scrolling a little bit too quick for me. Before the baseline was 1.4 milliseconds, afterwards was 1.4, so unfortunately we didn't get a good, meaningful performance improvement here, but you can see the should quote did drop from 13% to 7%, and it looks like some other code started taking up more of the time. And so I could continue my investigation here with Copilot. I could say like, hey, let's go ahead, let's try and optimize the crate. Write delegate, I could run a memory profile to go through and I could check the allocations that way. I could click the show create write delegate implementation. I'll be honest, I did run this before the talk and we actually created a PR because we were able to actually, switch over to the conversation. We were actually able to meaningfully improve this with Copilot. I'm not sure why it didn't improve today. I'd have to dig through the logic a little bit more. But our metrics did go from about 1.1 milliseconds down to 0.8 milliseconds. And while it doesn't seem like a whole lot, that's a 25% win. A lot of times, like, the improvements that you get with software, it's not going to be a magical, like, oh, I fix this one line and it was 10x faster. It's these small little paper cuts all over your code base that are really just tripping you up and really starting to hurt you. And so with the Copilot agent, you can just have it go through and run these and try and optimize as you have time. And so we didn't get the optimization here, but one of the interesting follow-ups that I kind of want to leave everyone with is we now have this nice reusable artifact that goes with the repository. We can use this for additional profiling. And I can also use this to learn about the profiling that I'm doing. And so I could ask Copilot, since we did a single pass instead of multiple passes, why is this not faster? And it's not just, you don't just have to use Copilot to invoke tools and get these things done. You can use it to actually learn and kind of grow as a software engineer as well. I'll be honest, Copilot has found some very interesting optimizations for me in the past, and I've asked it, like, I don't understand what's happening here, and it's like, oh, did you know this, like, weird quirk about the JIT will stop inlining code after so many IL instructions in a method? And I had no idea, and I learned something new. And so you can use Copilot to not only kind of achieve the results that you're looking for, but you can also use it to learn and grow as a software engineer as well. And so with that, just want to switch back to the presentation deck. Some next steps. If you get a chance, go see if you can reproduce the same. Hopefully, by reproducing the same, I mean you actually reproduce a performance win and you don't reproduce the non-win that I got here. There is the CSV helper library as a resource. It's uploaded in the GitHub repo for this session. The author is super nice guy, will work with you. The CSV helper optimization PR is there, and then the profiler agent documentation. And then some other interesting related sessions. Later on today, Mads and I are going to be doing breakout session 207 on the main stage. And we're actually going to show off not only the profiler agent, but the debugging agent and creating unit tests as well, and how we actually use that on Visual Studio to improve the performance of Visual Studio and improve the reliability of Visual Studio. And so with that, thank you. I can take any questions. The question was, what time is the breakout session? Breakout session is at 4 o'clock.
How do you inject functional testing into your loop? Like, what if your
Okay, so the question was, how do you inject functional testing into the group into the loop if Copilot broke the functionality? So a lot of times you can tell Copilot, these are the tests that I have. Please run these after any of the optimizations that you've done, and then it will go through and use that as a validation layer. In the breakout session that we're doing later, we're actually going to use Copilot's, the profiler's ability to profile a unit test to profile the unit test to improve the optimization. And because it's using the unit test, it's like, oh, hey, I can use that for functionality as well. So it'll do that.
Can you use the Copilot to help interpret the results that the profiler gives you? You know,
Yep.
the profiler gives you just like, and we have like a ginormous stack, and so like trying to find high functions in this giant stack is really hard.
Yep. Yeah, so the question was, can you use the profiler to help you interpret the results that you're seeing in the trace? And the answer is yes, you can totally do that. You can ask questions of it. I'm actually going to flip back here real quick. So the first thing you can do is you can just hit this analyze button. We can run it today, and it'll say like, hey, can you suggest some optimizations for this trace? It's going to go ahead. It's going to look at the top functions. It's going to look at the call path, the hot path. It's going to look at the caller callee, and it's going to try and digest some of the ideas. This is just the main trace that opens up, and then there's this top insights. So we have top insights that fire on known bad patterns in .NET, C++, like trying to think of a CPU one. So a CPU one might be like calling index of on a linked list because it's got to iterate through, or calling contains on just a regular list. It'll say something like, hey, you should consider using a set here instead because it can hash it and it can get direct access instead of having to iterate through. If you don't have any of those top insights, you can always click the generate top insights, and Copilot will go through, it'll read your trace, and then it'll come up with some ideas. And so in this case, you can say it's removing repeated null checks. It can send you to the source code. You can click on the optimize. There's an IEnumerable with a concrete type, so you can avoid that to remove the boxed enumerator, I believe, and then construct a stream writer with a large buffer, so saving on your buffer costs. In this case, when you call the analyze on that trace, it doesn't always pick up on the fact that it ran in a benchmark, and so it might try and optimize some of the surrounding benchmark codes. You have to be a little careful there because I really don't care to optimize that. I want to optimize the user code instead. So, cool. Thank you.